In this example, we have an acceleration function in meters per second squared that's given by a of t is equal to 6 sine t. And we're also given the initial velocity, which is v of 0 is equal to -1 meters per second. In the first part, it says find an equation for v of t, which is the velocity. And so we know that the acceleration is the derivative of the velocity. So to find the velocity, we have to find the antiderivative and work backwards from the acceleration. So let's first do that. We'll find a function. So if I work backwards from a of t, that's going to give me minus 6 cosine t plus our constant. And in order to find our constant, we're going to use this initial value right here. So we're going to plug in when t is 0, we get out the velocity is -1, and then we can solve for c. So I'm going to plug in 0 and set this equal to -1. So when we do that, -6 cosine of 0 is -6. So c is going to end up being 5. So for part A, our final answer is going to be v of t is equal to -6 cosine t plus 5. So that's our velocity function. In part B, it says find the object's displacement in meters from 0 to 3 seconds. So displacement is basically, we're thinking about distance. So we have to work backwards again from the velocity and find the antiderivative of velocity. But then we also want to do that from 0 to 3. So we're going to integrate using a definite integral, and the limits are going to be from 0 to 3. From 0 to 3, I am integrating the velocity to find the displacement. Okay, so taking the antiderivative, I'm going to get -6 sine of t plus 5t plus a constant. And I'm going to evaluate that from 0 to 3. So I'll continue down here. So I'm going to plug in 3. So I get -6 sine of 3. Now notice there's no degree sign here. So this is going to be in radians. Plus 5 times 3 plus my constant. And I'm going to subtract what I get when I plug in 0. -6 sine of 0 plus 5 times 0 plus my constant. Now, because I'm taking constant minus the constant, we don't really need to know what it is because it drops out. When we're doing a definite integral, we don't have to worry so much about the constant. So now let's see. -6 times sine of 0, that's 0. 5 times 0 is 0. So this big mess right here is equal to 0. Now, when I put in on the calculator -6 sine 3 plus 15, keeping in mind, remember to make sure you're in radians. When you put that in, you're going to get 14.15327995. So this is going to be in meters because remember, this is displacement. Okay, so what this tells us is the object moved in one direction and then it moved in a different direction, and that net direction is 14.15327995 meters. So for an example of that, let's say I move 3 meters in front but I back up 5 meters. So that would be a displacement of -2 because my final point where I rest is going to be -2, means in that direction, in the negative direction from where I started. So this is the net displacement, where it includes the direction, okay? Now, in the next part, in part C, it's asking for the total. So if I moved 3 meters in front and then I backed up 5 meters, I would have traveled a distance of 8 meters. That's the total distance traveled, not the net displacement. So that's why we have to approach part C a little bit differently. Now, when we look at the graph of the velocity, I'm going to exaggerate this so that it makes it easier to see. So our graph, here's 0. Our graph is going to look something like this. And again, I'm exaggerating this so that it's easier to see. So here's 3, here's 0. When the area is above the x-axis, that means you're moving in the positive direction. When you're below, you're moving in the negative direction. So I need to find the areas of both of these, ignoring whether it's negative or positive, and just add them together. Just like when I gave you the example, if I move 3 feet forward and then I move 5 feet back, I moved a total of 8. In that case, I don't care about the direction. I just want the total that I traveled. So what we're going to do is we're going to find the area from 0 to whatever this point is here. And then we're going to find the area from whatever this point is here up to 3. And then we take the absolute value and add them together because we don't care about the signs in this case. Now we need to find that intersection point so we know where to start and stop our integrals. So you can use your calculator and use the intersection method, or you can just set your equation equal to 0, however you prefer to do it. And what you're going to get is where that point crosses the x-axis is going to be 0.5856855. So we have to set up 2 integrals. I'm going to set up the integral for the yellow area, and that's going to be from 0 to 0.5856855. That will give me the yellow area. And because the yellow area is below, I want to negate that because I know if I do the yellow area, that's going to be negative. Or you can just figure out what that area is, and when it comes out to negative, you just make it a positive, whichever way you choose to do it. So let's do it that way. So I'm going to take our function. Let's see. -6 cosine of t plus 5. This is our velocity function. When we integrate it, we get our displacement function. And then I'm going to go from this point of 0.5856855 up to 3. So we're splitting the integral in half, or not in half, but we're splitting it into 2 pieces because we have one piece that's negative and one piece that's positive. So I'm going to do the same thing here. And I forgot my dt here. I'm going to squeeze it in. All right, so when I evaluate this, I'm going to get 0.388157, and that's going to be negative. But we know we want to do the absolute value, so then you want to make sure that you make it a positive. And then you want to add it to this area. When I integrate this second part, I'm going to get 14.541477. So I'm going to add this area, which is the yellow part over here. And then I'm going to add that. This is my pink area right here. So I'm going to add those together to get my total distance. So when I add these two together, I get 14.9296,287 for our total distance, and that's in meters.